Wait lang. Ayan. Okay. So once again, good morning everyone. So this time our topic is about, of course, cloud computing. No? Uh, the whole idea of enterprise architecture is to enable the enterprise to address orders of magnitude increase in complexity and orders of magnitude increase in the rate of change. Now, therefore, if you have enterprise architecture and if you have made that enterprise architecture explicit, and if you have designed it correctly, you should be able to change the enterprise and or formalisms. No, that is a systems manual or automated with minimum time, minimum disruption, and minimum cost. So material handling aspect of your enterprise based on cloud computing, and you may not want to change your strategic or core systems. However, if you wanted to change any automated system, and if you have enterprise architecture designed for accommodating complexity and change, then you should be able to be move the enterprise records off-site to run on the different data storage technologies and or different database management system product. So you need also to redefine the transaction flow based on different technology characteristics and or recompile your instruction with different compiler products. Reconstruct the data network, of course, and address structures for storing your records and provide programs external to the enterprise, running them on different operating system. Okay? We need to relocate the responsibility for producing the work products, of course, to an agency outside of your jurisdictional control, possibly using different formatting products, and redefine the control structure based on the different technological constraint and integrate those changes into the programmatic instructions. And you need to change your technology in motivations, no? Your technology objective and strategies, of course, and based on the cloud structure to identify the associated risk and modify your business rule appropriately. So if you have your enterprise architecture stored on a repository, I think no, I would simulate those changes before I actually made any of them to make sure I did not introduce any discontinuities of this functionality or that would disrupt the enterprise business. So to give us more details about the topic, let us all welcome our first presenter this morning.
Okay, sir. Thank you, sir, for that introduction. So, by the way, my name is Sir Lester Mendoza, and I will be discussing about cloud computing. So, let me just give some introduction what cloud computing is. So, cloud computing is a general term that is used to describe a new class of network-based computing that take place over the internet. And basically a step on from utility computing, and it is a collection or group of integrated and network hardware, software, and internet infrastructure, or simply called platform. Using the internet for communication and transport provides hardware, software, and networking services to clients. And these platforms hide the complexity and details of underlying infrastructure from user and applications by providing very simple graphical interface or the API or the applications programming interface. In addition, cloud computing is the platform that provides on-demand services that are always on, anywhere, anytime, and any place. Pay for use and as needed, elastic scale up and down in capacity and functionalities. The hardware and software services are available to general public, enterprises, corporations, and businesses markets. And also, cloud computing is an umbrella term that is used to refer to the internet-based development and services. So there are several characteristics that defines cloud data, application service, and infrastructure. So first, cloud computing is remotely hosted. So when we say remotely hosted, it is the services or data are hosted in remote infrastructure. Ubiquitous access services or data are available from anywhere. commodified, the result is a utility computing model similar to the traditional utilities like gas and electricity. You pay for what you want. So how about cloud architecture? So when we say cloud architecture, it is defined that the technology components that are combined to build a cloud. So where resources are pulled through virtualization, technology, and shared across a network. The components of a cloud architecture, so included here is the front end and the back end platform. So when we say front end platform, as you can see at your screen, the client or the service value nets or the device that used to access the cloud. Next is one or more back-end platforms, which is the servers and the storage. And also included here the cloud-based delivery methodology and the network to connect cloud clients. Again, servers and storage. Cloud computing also is a shared pool of configurable computing resources. On-demand network access provisioned by the service provider. So there are characteristics in cloud computing. So first is the common, which is the low-cost software, virtualization, service orientation, advanced security, homogeneity, massive scale, resilient computing, geographic distribution. In the essential characteristic, resource pooling. So when we say resource pooling, the IT resource, which is the network, server, storage, application, and other services that are presented and shared across multiple applications and occupant in uncommitted manner. Broad network access. So when we say broad network access, the computing services are generally provided over the standard networks and heterogeneous devices. Rapid elasticity. So the rapid elasticity should have IT resources that are able to scale out and quickly and as a needed basis. Whenever the user or the client requires services, it is provided to him or her and it scale out as soon as its requirement gets over. So that's the rapid elasticity. So when we say measured services, uh, the different resources utilization is tracked for each application and occupant, and it will provide both the user and the resources provider with an account of what has been used. And of course, the cloud computing is on-demand self-service. So when we say demand self-service, the cloud computing services that not require any human administrators. User themselves are able to provision, monitor, and manage computing resources as needed. Okay. So how about the cloud service model? So when we say services model, it came mainly in three types of service model. First is the software as a service or the SaaS. Second, the platform as a service or the PaaS. And lastly, the infrastructure as a service or the IaaS. So choosing between them requires an understanding of these cloud models. So first is to evaluate your requirements and finding out how the chosen model can deliver uh, your application intended to set of workflows. So that's the different cloud service model. So let's proceed first to SaaS, the maturity model. So from level 1 of SaaS, ad hoc custom one instance per customers only. In level 2, configurable per customer. Level 3, configurable and multi-tenant efficient. Level 4, scalable, configurable, and multi-tenant efficient. Okay. So these are the different cloud computing layers. From cloud computing layers, first is the application service. Included here the MS Lives, Exchangeable Labs, IBM, Google Apps, Salesforce.com, Quicken Online, Zoho, and Cisco. While in application platform, Google App Engine, Mozo, Force.com, Engine Yard, Facebook, the Heroku AWS, and from server platform layer, 3 Tera, EC2, Slice Host, GoGrid, RightScales, Linode. Storage platform included here the Amazon S3, the Dell, and Apple. Okay. So just to give some other info about SaaS model, SaaS or software services is a model that gives quick access to cloud-based web application. So the vendor controls the entire computing stack, which you can access using a web browser. So this application run on the cloud and you can use them by paid license subscription or for free with limited access only. So that is the uh, software as service model. Okay. So from the service layer, included here services, application, development, platform, storage, hosting, and it's divided from application focus, infrastructure focus. So here are the different basic cloud characteristics. So when we say the no need to know in terms of the underlying details of the infrastructure, applications interface with the infrastructure via the APIs. Then the flexibility and elasticity allows this system to scale up and down at will. Included here, utilizing the resources of all kinds, CPU storage, server capacity load balancing, and databases. So the pay as much as used and needed type of utility computing and the always on anywhere and any place. So we all know that cloud is internet based. So we have access here anytime and anywhere. So cloud are transparent to user and applications. They can be built in multiple ways. Branded products, proprietary open source, hardware or software, or just off-the-shelf PCs. So in general, they are built on cluster of PC servers and off-the-shelf components, plus open source, open combined with in-house application and or system software. So also, software as services is a model of software deployment where an application is hosted as a service provided to customers across the internet. It alleviates the burden of software maintenance or support, but user relinquish control over software version and requirements. In terms that are used in Spear, included here the platform as services and infrastructure as service. So I also included here the virtualization. So virtual workspace, an abstraction of an execution environment that can be made dynamically available to authorized clients by using well-defined protocols. And resource quota or the CPU memory share and software configuration such as operating system and provided services. So also included here the virtual machine. So abstraction of a physical host machine, hypervisor intercepts and emulates instruction from virtual machines and allow management of virtual machines. VMware, Xen, Oracle. So there are many virtual machines that we can use. So provide infrastructure, API plugins to hardware or support structure. So this is the presentation or image included in virtual machine. So VM technology allows multiple virtual machines to run on a single physical machine. So what is the purpose and benefits of cloud or cloud computing? So cloud computing enables companies and application which are system infrastructure dependent to be infrastructureless. By using the cloud infrastructure on pay as you on demand, all of us can save in a capital operational investment. So clients can or the user put their data on the platform instead of their own desktop PCs on their own servers, which is efficient for the client. They can put their applications on the cloud and uses the servers within the cloud to do processing and data manipulations. So when we say cloud sourcing, so why is this become a big deal? Because it's using high scale or low cost providers. Anytime or place access via web browser or what we call the ubiquitous access. Rapid scalability, incremental cost, and load sharing can forget need to focus on local IT. So what are the concerns? So when it comes in performance, reliability, and SLAS, so it's more recommended to use cloud. So control of data and service parameters, application features and choices, interaction between cloud providers, no standard API, mix SOAP, and REST. So privacy, security, compliance, trust is here. So these are the some commercial clouds so offerings. So Amazon, Verio, Beehive, Moso, if you're familiar with that companies. So next is the cloud taxonomy. So or the different branches of cloud. So first is the infrastructure services or the IaaS. So under that, we have storage, compute, services management, and cloud software, uh, data, compute, cloud management, appliances, file storage, and the second is the platform services, the general purpose, business intelligence, integration, development and testing, and of course, the database. Software services, so these have many branches, the billing, financials, legals, sales, desktop productivity, human resource, content management, backup and recovery, CRM, document management, collaborations, social networks, and others. And every branch of cloud computing have sub branches. So how about the cloud storage? So several large web companies are now exploiting the fact that they have data storage capacity that can be hired out to others. Allows data stored remotely to be temporarily cached on desktop computers, mobile phones, or other internet linked device. So Amazon's Elastic Compute or the Cloud EC2 and Simple Storage Solution or the S3 are well-known example. So Mechanical Turks is under that. So next is the opportunities and challenges when using cloud. So the use of the cloud provides several opportunities. It enables services to be used without any understanding of their infrastructure. And also, cloud computing works using economies of scale. It potentially lowers the outlay expense for startup companies as they would no longer need to buy their own software or servers. Cost would be by on-demand pricing. It depends on the subscription that the companies subscribe. And vendors and service providers claim cost by establishing an ongoing revenue stream. Data and services are stored remotely but accessible from anywhere, which is one of the biggest factors of using or benefits of using cloud. In parallel, there have been backlash against the cloud computing. First, use of cloud computing means dependence on others and that could be possibly limit flexibility and innovation. The others are likely become the bigger internet companies like Google and IBM who may monopolize the market. Some argue that this use of supercomputers is a return to the time of mainframe computing that the PC was a reaction against. Security cloud proves to be a big issue. it is still unclear how safe outsources data is when using the services. Ownership of data is not always clear. And also, there are also issues relating to policy and access. If your data is stored abroad, whose policy do you adhere to? What happens if there's remote servers goes down? Okay, what happened to your file? How will you then access the files if the files uh, can't open or it may be corrupted? There have been cases of users being locked out of accounts and losing access to data. So I recommend to back up necessary files and important files. So these are the advantages of cloud computing. So when it comes in, it costs so lower. You do not need a high-powered and high-priced computer to run cloud computing's web-based applications. So you can also use here your mobile phone, so you can access the cloud or the storage or your files. Since applications runs in the cloud, not on the desktop PC, your desktop PC does not need to process power or hard disk space demanded by traditional desktop software. So in desktop PC, we can up what we call here to upsize or to lessen the file storage capacity of the file that we store in our cloud. So one of the advantages of cloud computing. So when you are using web-based applications, your PC can be less expensive with a similar hard disk, less memory, more efficient processor. But in using cloud, so of course, like in Google, since we have account here in PL Moon, which is paid, so we have an access which is unlimited, I think. But yeah. So next. In fact, your PC is this scenario does not even need a CD or DVD drive as no software programs have to be loaded and no document files need to be saved in your PC or laptop. Another advantage is improved performance. With a few large programs hugging your computer's memory, you will see better performance from your PC. Computers in a cloud computing system boot and run faster because they have fewer programs and processes load into memory. Reduce software costs. Instead of purchasing expensive software applications, you can get most of what you need for free. So most cloud computing applications today, such as the Google Doc Suite or Suite, better than paying for similar commercial software, which alone may be justification for switching to cloud application. Another advantage is instant software updates. Another advantage of cloud computing is that you are no longer faced with choosing between obsolete software and high upgrade costs. When the application is web-based, updates happen automatically available the next time you log into the cloud. So when you access a web-based application, you can get the latest version without needing to pay for or download an update. Improve document format compatibility. You do not have to worry about the documents you create on your machine being compatible with other users' application or other devices. So there are potentially no format incompatibilities when everyone is sharing documents and application in the cloud. So when you stored files in your in cloud, so there is no compatibility issues. And also, uh, cloud computings have different disadvantage. So first is it requires a constant internet connection. Of course, it is impossible if you cannot connect to the internet. So since you use the internet to connect for both your applications and documents, if you do not have an internet connection, you cannot access anything, even your own documents if you have no internet or unreliable connection. So another disadvantage is does not work well in low speed connections. Similarly, a low speed internet connection such as the found with dial-up services make cloud computing painful at best and often impossible. So web-based application requires a lot of bandwidth to download as do large documents. Also, disadvantage is features might be limited. So this situation is bound to change. It depends on the subscription of the cloud. So, but today, many web-based applications simply are not as full featured as desktop-based application. For example, you can do a lot more with Microsoft PowerPoint than with Google presentation web-based offering and many Microsoft products. And last, the disadvantage is it can be slow. So even with a fast connection, web-based application can sometimes be a slower than accessing a similar software program on your desktop PC. Everything about the program from the interface to the current document has to be sent back and forth from your computer to the computers in the cloud. If the cloud server happened to be backed up at the moment, or if the internet is having a slow day, you will not get instantaneous access you might expect from a desktop application. Another disadvantage here is that when you store files online or in the cloud, so again, if you have no internet connections and if your PC is like the specs is lower that is lower, so you can't access the files or your own files online if your PC or device is slow. Okay, meaning to say, it is recommended to use cloud uh, when your PCs or mobile devices and your internet connection is uh, faster. Okay, so that is the advantages and disadvantages and pros and cons of using cloud computing. So that's all. Thank you, sir.
Okay, so again, thank you very much for a comprehensive discussions about the cloud computing. No? So, as more facet of work and personal life move online and the internet becomes a platform of virtual human society, a new paradigm of large-scale distributed computing has emerged. No? So, web-based companies such as Google and Amazon have built web infrastructure no, to deal with the internet scale data storage and computations. Now, if we consider such infrastructure as a virtual computer, it demonstrates the possibility of new computing models. So, centralize the data and computations on the supercomputer with unprecedented storage of computing capability, which can be viewed as a simplest form of cloud computing. So, again, as our presenter mentioned, cloud computing is an internet-based system development in which large scalable computing resources are provided as a service over the internet to users. The concepts of cloud computing incorporate web infrastructure, software as a service, Web 2.0, and other emerging technologies, and has attracted more and more attention from industry and research community. Let's say, for example, from the view of end user, the cloud computing service moves the application, software, and operation system from desktop to the cloud side. So, which make users be able to plug in anytime from anywhere and utilize large-scale storage and computing resources. On the other hand, no, the cloud computing service provider may focus on how to distribute and schedule the computer resources. Nevertheless, the storage and computing on massive data are the key technologies for a cloud computing infrastructure. So we can define actually cloud computing to describe both a platform and type of applications, because a cloud computing platform dynamically provides, configures, reconfigures, and they provide servers as needed. And server in the cloud could be physical machines or virtual machines. So advanced clouds typically include other computing resources such as storage area networks o yung SANs, no? Network equipment, firewall, and other security services. So in the design and implementation of a conceptual framework for a cloud computing platform shall be described alongside with the mathematical model structure that supports the design while taking into consideration at this design stage, no? Storage and computing of massive data and ability of the cloud computing infrastructure. So, excuse me. A cloud is a proof of virtualized computer resources that can host a variety of different workloads, including batch-style back-end jobs and interactive user interfacing applications. It also allow workload to be deployed and scaled out quickly, no, through the rapid provisioning of physical or virtual machine. And it can monitor resources used in a real time to enable the rebalancing of allocations when needed. So support redundant, of course, self-recovering, high scalable programming models that allow workloads to recover from many unavoidable hardware or software failures. No, again, the emerging trend, no, the construction and implementation of cloud computing platform is, of course, is to implement a platform for a domain-specific cloud computing service with large-scale web text mining as targeted applications. No? So in a cloud computing paradigm, of course, it is a relatively new way of referring to the use of shared computing resources, and it is an alternative to having local servers handle the application. Again, cloud computing groups together large number of computer servers and other resources, and typically others than their combined capacity on and in demand, no? Or on demand, pay per skill basis, no? So again, the end users of a cloud computing network usually have no idea where the servers are physically located, and they just spin up, no, their application start working, no. So cloud computing is fully enabled by virtualization technology and virtual appliances, as our presenter mentioned earlier. A virtual appliance is an application that is bundled with all the components that it needs to run, no, along with a streamlined operating system. In a cloud computing environment, a virtual appliance can be instantly provisioned and decommissioned as needed without complex configuration of the operating environment. So, the flexibility is the key advantage, no, sabi nga ng ating presenter, to cloud computing, in what distinguishes it from other forms of grid or utility computing and software as a service. So the ability to launch new instances of a new application with minimal labor and expenses allows application to provide, of course, scale up and down rapidly, no? And so on. When it comes to the layers in cloud computing, no, there are several recognized layers in cloud computing. So the vendors in these layers have very different service offering and operating models. Some vendors concentrate on building and maintaining a huge data center, while others concentrate on building a user-friendly and feature-rich applications. So the layers from bottom to top are infrastructure, storage, platform, application, services, and the client. So for the infrastructure, no, at the bottom is the infrastructure of the service, so, or the platform virtualizations. And the other is with the storage layer, you get database or something similar and pay per gigabyte per month. No? The platform layer has solution stacks such as Ruby on Rails, LAMP, Python, Django, and others. No? The application layer consists of applications that are offered as services. The most famous are the probably Salesforce.com, Google Docs, but there are hundreds, if not thousands, of applications that can purchase as services. Now, popular web applications such as Facebook, LinkedIn, are cloud services. In these cases, the customer probably does not know if the application is run in a scalable data center in an ordinary hosting service or in the service provider's basement. The services layer contains interoperable machine-to-machine operations over the network. And the clients at the top of the stack is the client layer, no? Which contains the users of the cloud. Clients are, for example, desktop users, either TIN or T client yan, and mobile users like Symbian, Android, iPhone, and so on. No? So the architectural considerations in designing an application to run a visual or a virtual appliance in a cloud computing environment, it is very different than designing it for an on-premise or SaaS deployment. No, to be managed, of course, to be successful in the cloud, my application must be designed to scale easily, tolerate failures, and include management tools. Organizations and individuals can benefit from mass computing and storage provided by large companies with stable and strong cloud architectures. On the other hand, companies that desire to build massive, scalable environments utilizing virtualization and cloud computing will increase their future margin of success greatly. No? So we have also conceptual model design stages, guidelines. This will be the best way to follow some basic application design guidelines. We need to start simple, split application functions and couple loosely, network communication, consider the cluster also. So to deploy a clustered system, determine the right collection of servers that yield efficient application performance, taking any needed functional redundancy into account. Like say, for example, 2 web or application and 2 database servers. So you can then scale the applications by replicating the ideal cluster size and splitting the system load across the servers in the cluster. So advantages of cloud computing when it comes to scalability are in expensive testing, reduce risk, ability to segment the customer base, auto scaling based on application load. So when it comes to fail, inevitably, an application will fail. We need to accept the fact that no matter what its environment, when you design an on-premise or SaaS application, you typically consider very doomsday scenarios. So the same must be true for designing an application that runs in the cloud. We need to build in resiliency and fault tolerance. So to tolerate failure, application must operate as part of a group while not being too tightly coupled to their peers. So each piece of the application should be able to continue to execute despite the loss of other functions. Asynchronous interfaces are an ideal mechanism to help application components tolerate failures or momentary unavailability of other components. We can distribute the impact of failure. So with a distributed cloud application, a failure in any one application cluster affects only a portion for the application and not the whole application. So by spreading the load across multiple clusters in the cloud, you can isolate the individual cluster against failure in another cluster. So get back up quickly. So automate the launching of new application cluster in order to recover quickly. Because application component must be able to come up in an automated fashion, configure themselves and join the application cluster. Because cloud computing provides the ideal environment for this fast startup and recovery process. For the data considerations, so wait lang. When an application fails, let's say, for example, data persistence and system state cannot be taken for granted. So to ensure data preservation, put all data on persistent storage and make it sure it is replicated and distributed. Backupping is very important. If system state is stored and then used in the recovery process, treat it like data so the system can be restarted from the point of failure. So, again, as I mentioned earlier, test your doomsday scenario. Cloud computing makes it easy to bring up an instance of your application to test various failure scenario. Because of the flexible nature of the cloud computing, it is impossible to simulate many different failure scenarios at a very reasonable cost. Single instances of a system can be take offline to see how the rest of the application will respond. Likely, multiple recovery scenarios can be planned and executed ahead of any real production failure. And be aware of the real cost of failure. Of course, the ideal situation is avoiding any application failure. But what is the cost to provide that assurance? No? So a large internet company once said that they could tolerate failure as long as the impact was small enough as to not be noticeable to the overall customer base. And this assertion came from an analysis of what it would cost to ensure 7/9 of applications uptime versus the impact of failure on the portion of the customer base. So, deploying cloud application as virtual appliances makes management significantly easier. So the appliances should bring with them all of the software they need for their entire life cycle in the cloud. More important, they should be built in a systematic way akin to an assembly line production efforts as opposed not to a handcrafted approach. So the reason for this systematic approach is the consistency of creating and recreating images. Now, when building appliances, it is obvious that they should contain the operating system and any middleware components they need. So less obvious are the software packages that allow them to automatically configure themselves, monitor and report their state back to a management system, and update themselves in the automated fashion. So automating the appliance configuration and update means that as an application grows in the cloud, the management overhead does not grow in proportion. So the advantages of designing your application management in the cloud include reducing the cost and overhead of preparing the application for the cloud, reducing the overhead of bringing up a new instances of the application, eliminating application sprawl, and of course, reducing the chance for mistakes as the application is scaled out, failover, upgraded, and others. So, the cloud system, processing resources and scheduling modeling result is, of course, is important. No, the complete model must be the whole scheduling process ranging from data generation, showing newly regenerated data on queued to process data in the cloud. No? So, to cut in short, no, from rapid application testing in development environment, cloud computing represent an exciting opportunity to bring on-demand application to customers in an environment of reduced risk, enhanced reliability. So, I think it is advisable for you now to research on some cloud computing, as I mentioned last time, that maybe this during your time for in Capstone project, that you will be able to consider developing software with the application of cloud computing, because researchers and information technology stakeholders monitoring a large number of clients should see the need to embrace the new development in data warehouse storage, enhancement and increased performance to help improve the total throughput of their applications. So I think that's it. Okay, so andito ba yung next presenter natin? Sino bang susunod? Sino ang susunod? Si Sir Suarez ba? Enroll pa rin? Wala si Sir Suarez. Alam nyo ba kung si Sir Suarez naka-enroll pa rin o nag-ano na? Wala si Sir Suarez, ano? Okay, so since wala si Sir Suarez, actually ready naman ako to present, But give him a chance naman next meeting kung talaga pumapasok pa siya. Pag hindi na, ako na mag-discuss next meeting. Okay pa? So, Dalawa lang naman yung presenter natin. So see you next meeting. Ang topic po natin ay Synchronous Industrial Revolution pala, 4.0 and Education 4.0. And baka po may gusto diyang mag-discuss ng design system trends and best practices. Open po yung topic. So ipopost ko mamaya sa ating group. As additional points po sa inyo yan, okay? So if you don't have any question, ay Sir Lester, pakitanggal po ng iyong sharing para makapicture tayo as proof of attendance po. Teka lang, at ang aking snipping tool hinahanap ko pa. Snipping tool. Ayan. Ay, nag-raise ng hand si Sir Cabrias. Sir Cabrias, ano pa?
Sir, ask ko lang po yun sa project.
Oh, sige.
Ano nga ba yun? Yung sa scope natin, ano pa ba yung target natin doon?
Probably, syempre, system implementation to, no? So, what I'm looking at, of course, is meron kayong database, syempre, database manipulation, no? We need to consider the two-way authentication. Dapat may ganun po yung system natin. Syempre, bukod po doon sa mga available modules ng inyong, ng inyong system, no? So, we need to consider, of course, the ano ba yung mga roster natin dito? Yung validation, yung common sa software development. Validation, generation of reports. Kung kayo po ay online, so dapat online kapag present nyo siya. Then, syempre yung login natin, anong tawag natin doon? Audit trail. Andyan din dapat syempre may database, din naman pwedeng wala, no? Yun yung mga basic. Basta yung basic needs po sa software development. Ang siguro add-on ko na lang talaga is yung at least mayroon two-way authentication po siya. Kasi para maiba naman tayo sa regular na ginagawa ng mga student na basic,
Sige, sir.
Pero i-post ko na lang, sige, post ko rin doon sa group natin kung ano yung mga requirements pa.
Okay,
Yun lang
sir,
but provided of course dapat syempre kapag yung user level is also important, kasi pag yung mga panel natin kadalasan ang tinatanong ng panel. Okay, sige, pakita nyo sa amin yung admin account. So pakita mo yung admin account. So how about the second level? O how many level of user account ba mayroon? Kung meron ba yung clients, meron and so on. So ganun yung mga consideration ng panel. So mahalaga yon yung ano yung kaibahan ni user panel ng user account, no, per user account. There are certain cases din naman na kailangan pa ng approval ni user account na to para makapag-generate itong isang user account, yung mga ganon, no. So sa validation yon, so kailangan may validation, mga ganung bagay, no. So syempre, alam nyo naman na syempre nandiyan yung mga primary consideration, yung ARD, yung structural design sa documentation, no? Hindi mawawala 'yon. Okay? Sa documentation. Hindi pala nakikita sa akin lahat yung
Sir, wag mo masyadong mahirap yung requirement, ha? Ipopost mo.
Hindi yan. Ano ba kayo talaga? Tiwala lang daw. Kayo naman yun nasa inyo naman yung paano nyo ipipresent sa panel Mabait naman ang panel natin
Sure yun, sir, mabait yun, ha?
Oo. Mabait pagka bagong gising.
Sure na sure kayo, sir, ha?
Oo, kasi pag yun, huntingin namin yun.
Maglilit na group kayo. Natatawa ko pag may tanong, bigla nawawala may question yung panel, bigla nawawala lahat. Ay, sorry, pagbalik. Sorry po, nawala po kami dito. Pagbalik, may sagot na. So, yun lang naman. Kadalasan ng panel naman, depende sa kung anong topic ninyo. Nag-i-invite ako ng panel, depende sa topic ninyo.
Sige.
So, okay na? Kung wala nang tanong, bye-bye and good luck sa next subject ninyo.
Sige, sir. Thank you.
Thank you, sir. Salamat
Bye-bye.
po.
Okay, sige.